Hey guys, my name is Jack, and I'm here to talk to you guys today about artificial neural networks. I would like to cover an introduction of what a neural network is, how it works, some of its uses, and at the end we'll have a little demo. An artificial neural network is loosely based on a biological neural network. So first we should talk a little bit about biology. This is a neuron in our brain. The dendrites are what's on the left. They are the ones that are receiving any inputs from other neurons, while the middle part, the cell body, is the part that's processing the information. The right side, we have the terminal axons, which is where the outputs are sent through, and that's where it connects to the other neurons to communicate. Figure A is just another picture of a neuron. Figure B is the artificial neural network equivalent, which is a node, where in the x1, x2, and x3 are the inputs. The f of x is the node itself, and y is the output. Figure C is just two neurons connecting to the synapse, which is just where the terminal axons connect. Figure D is just a more fuller neural network where the different nodes connect. There are three different layers to the neural network: the input layer, hidden layer, and output layer. The input layer is usually where the inputs are inputted. The hidden layer is how deep a network is. So if you guys ever heard of a deep neural network, it just means that there are more hidden layers. And the last layer is the output layer, which is what the output is and how it will. That is our output for our neural network. Let's just see how it works. Let's assume for this example we have two inputs, both ones, and we want an output of 0. Each layer is connected through a series of connections that are weighted. These values for the weights are usually between 0 and 1, and because they can be different varying weights, that means that certain connections may be heavier than other connections. So in order to calculate the value of the hidden layers, we use the layer before it and the weights on each of the connections. Each node's value will depend on the input and the weight. So in order to find the value, we first multiply the input by the weight, and we sum up all of those connections for each of the nodes. So for the very top node on the hidden layer, it'll be 1 times 0.8 plus 1 times 0.2, which will equal to 0.1, and repeat that for all the nodes. But it's important to note that this sum is not the actual value of the node. First, we need to apply an activation function. There's different activation functions for different types of neural networks. So the first example is a unit step, which is also known as a stepwise function, where it only returns zeros and ones. This is good for like perceptron neural networks, such as like whether a neural network senses a light or not, or hears something or not. This goes the same for the sine function, which returns -1, zeros, and ones. So for our neural network, we'll be using a sigmoid function. Sigmoid functions and hyperbolic tangent functions are usually what's used for multi-layer neural networks. If you ask me why, I do not know, and most people do not know. There's no preference. There usually isn't a preference between the different types of sigmoid functions, because that's still like a really big mystery in the neural network community. Whether one function is better than the other. So if we apply the activation function, which in our case is a sigmoid function, to the sum of the nodes, we'll get those values for that hidden layer. And for next step, we need to do the same thing we did before. We multiply that by the weights to get the output. But if you remember from the very first slide, we said that we wanted our output to be 0, and we have 0.77, which means that this is not a good neural network. We're not even close. So like most things we do in life, we need to train to get better. And in order to improve our performance, we have to train our network just like we train ourselves. So in order to train our network, we need to use a method called backpropagation. And what this means is that we find the desired change we want to see, and we repeat that process to adjust the weights every time we train our network. So So first we take the derivative of the activation function, which in our case is a sigmoid function. we apply to the sum for each node and multiply by the margin of error, which for ours is negative 0.77. That'll give us the delta output sum, which represents the change we want to apply. So we apply this for the hidden layers in the middle. We find out the delta sum, the delta weights by dividing the delta output sum by the hidden layer results, and we will have the delta weights. We will then add the delta weights to our current weights and get our new weights. We do this for both layers. We do it for layers between input layer and the hidden layer, and this will be our new neural network with the weights adjusted through back propagation. In this iteration, we see that our calculated value is 0.69 instead of 0.77, which means our network is slightly better than our last. But it's not nearly good enough because it is still really, really far from our target, which is 0. So if we do this about 10,000 more times, it will probably be about fairly accurate, about like 0.999 or something to that degree. So what are some uses that we can use for neural networks? Popular uses are data processing and classification, which is what YouTube does to sort and categorize their videos, so that they can recommend you better videos to watch after you watch a certain type of video. Robotics, we can train robots to traverse terrain based on a neural network or feed us cereal. And another practical application is natural language processing. A lot of languages do not operate on the alphabet system, so many of the characters can be learned through a neural network to better recognize characters. Image recognition and processing is also a really big part of neural networks. I think recently Google has a thing where if you upload an image, it'll tell you approximately what it is. That's really, really cool because this allows a machine to tell us what a picture is. Neural networks are also really good at finding patterns that we as humans cannot see. It can do predictions through stocks and weather to help us, predict stuff. And finally, I would like to show you guys a little demo of a neural network. Here, this is a trained network already, where it recognizes digits from 0 to 9. So if I drew like 1 here, it'll recognize that it is a 1, and it is 100% confident that it's a 1. We can try with other digits. Some digits are harder than others. Zeros tend to be harder. Maybe 6s. 9. This is fairly accurate. 4s. 7. So the hardest one is probably going to be 8. And it is still pretty good. Even that. Yeah, we pulled it. So these are some of the credits that I have. The user syntax on YouTube is he runs a lot of tutorials on Python, and he has a lot of videos on machine learning, which I recommend you guys look into if you guys are really interested in neural networks and machine learning. Thank you guys.